Hello there, Nareg is here. Today we're going to talk about trigonometry. It's going to be an introduction to trigonometry. But first let's define the word trigonometry itself. So, metry actually comes from the word that means measurement. So it's a measuring. As for trigon, it means triangle. So it's a certain measurement related to triangles. And in this case, we need to take right triangle to make those measurements and especially talk about the different functions, the different trigonometric functions. So let's start. We need a right triangle. So let's call this triangle ABC. Of course, the side AC, it is called the hypotenuse. It is called the hypotenuse. I'm going to choose a certain angle. In this case, I'm going to choose the angle A, and I'm going to call it alpha. And of course, I'm going to study the functions related to this angle. So, the first one, we have three main trigonometric functions: sine, cosine, tangent. And sometimes we can even mention about cotangent. So, let's start with sine. Sine alpha, which is of course the same thing as the sine of the angle BAC is actually the opposite side, so it's the opposite side over the hypotenuse. What is the opposite side of A, the angle A? Very simple. A has this side, which is CB, directly opposite to it. So the opposite is BC. As for the hypotenuse, it's AC. And this is how you calculate sine alpha, which is sine of BAC, and it's the ratio of the opposite side over the hypotenuse. It's BC over AC. Now, the second trigonometric function is cosine. It is written as cos alpha. Cosine alpha, it's of course the same thing as cosine of the angle BAC. And in this case, it's the ratio of the adjacent side over hypotenuse. The adjacent side of alpha, it's directly the side next to it. Of course, it's not going to be the hypotenuse. So it's AB over AC. Alright? As for the tangent, a tangent itself, it's very simple. Tangent alpha, it's sine alpha over cosine alpha. So it's BC over AC over AB over AC. You simply cancel AC, AC. So whatever remains is BC over AB. So this is the tangent, the trigonometric function tangent alpha. As for the cotangent is the reciprocal function of tangent. So it's 1 over tangent alpha. Automatically it will be AB over BC. So in case you want to add about the cotangent, I'm going to add it in a different color. So cotangent alpha, it's 1 over tangent alpha is equal to AB over BC. I'm going to take again another angle. So the same triangle, I'm going to take the same example, the same triangle, which is ABC. It is right at A, AC is the hypotenuse, and I'm gonna be interested to find the trigonometric functions related to the angle C. So let's call angle C as gamma. Alright, what are the trigonometric functions? So we have sine of gamma is the opposite over hypotenuse. What is the opposite side of angle C or angle gamma? It's simply the side AB, right opposite to the angle gamma. It's AB over the hypotenuse. Hypotenuse is again AC. What is the cosine of gamma? Cos gamma, it's the adjacent side over hypotenuse. So gamma has the side BC directly next to it. So it's the adjacent side. Adjacent side, it's BC over hypotenuse, it was AC. What about the tangent? Tangent alpha, a tangent gamma, it's simply sine of gamma over cosine of gamma. So you simply say it's AB over AC, the whole fraction, of course, BC over AC. Here AC and AC cancel out. Whatever remains, it will give you AB over BC. As for the cotangent of gamma, it's equal to 1 over tangent gamma. So it's the reciprocal of tangent actually. It's BC over AB. So this is how you find the trigonometric functions. And of course, we can take an example with the values of a certain angle that we choose. But first I'm going to introduce you about the fundamental formula of trigonometry. How are we supposed to find that formula? After talking about this trigonometric functions, we're going to take one more time the same triangle. So we have a triangle ABC, and we're going to use Pythagoras Theorem. So from Pythagoras Theorem, we can deduce that AB to the power of 2 plus BC to the power of 2 is actually equal to the hypotenuse to the power of 2. It's AC to the power of 2. Now if I divide this relation, each term by AC squared, we're gonna get, so AB squared over AC squared plus BC squared over AC squared is equal to AC squared over AC squared. Alright? What about AB over AC? AB over AC is actually the sine of gamma. This was, let's say, our angle gamma, so we can say sine of gamma to the power of 2 plus what is BC over AC? It's the cosine of gamma is equal to 1. So from here we have this fundamental formula of trigonometry, which says sine squared of any angle, it could be alpha, gamma, any angle, plus cosine square of the angle in question, let's say in this case it was gamma, is equal to 1. And this is how you have this fundamental formula, and you can use it. It's going to be very helpful to find other identities, other formulas. So this was directly related to Pythagoras Theorem, and of course we were able to find this fundamental formula. Now, what about the particular angles that we can find them directly through, of course, our right triangle, but it's going to be some particular triangles like semi-equilateral triangle or isosceles right triangle. These triangles actually can give me the values of any trigonometric function related to particular angles. The particular angles are 0, 30, 45, 60, 90. So whenever I'm going to find sine of 0, cosine of 0, etc., I can simply use triangles, and from these triangles I will be able to find the values. So I'm going to first talk about the semi-equilateral triangle, and as you know, semi-equilateral triangle, it has a right triangle, a right angle here, and then this angle is considered to be 30, and this angle is considered to be 60. Now, if this side is, the hypotenuse is C, let's say the length is C, BC, it will be C over 2, and AB, it will be C square root of 3 over 2. So let's say I'm gonna be interested in calculating sine of 30. So I'm gonna use the formula sine 30 is opposite over hypotenuse. What is the opposite? It's BC, sorry, over AC. What about BC? BC, it's C over 2 over AC. So C over 2 over AC, which is C, it will give me simply 1 over 2. And this is how you find the sine of 30 degrees. You don't have to memorize. Once you have this triangle in front of you, you simply say, I'm gonna check the ratios, and I will be able to find the exact value of sine 30, cosine 30, etc. Now, let's say I'm gonna be interested in talking about cosine of 30 degrees, which is, of course, in this case, the angle A. Cosine 30, it's AB over AC. What is AB? AB is C square root of 3 over 2. AC is C. So the final answer will be square root of 3 over 2. Of course, once you're doing those calculations by using the calculator, it will give you a certain value, which is 0.8, etc. So that's, of course, not the exact value, just like square root of 3 over 2. This is the exact value. Now let's say I'm going to be interested in sine 60. Sine 60. It's the opposite. Opposite, it's AB over hypotenuse, it's AC. It's C square root of 3 over 2 over C. So it will give us square root of 3 over 2. And again, this is how you are able to find sine of any angle, particular angles. I'm talking here, of course, 30, 60, 45. I'm going to talk also about 45. So one of the important things that we should pay attention to in this case, as you can see, cosine of 30 is equal to sine of 60. So for complementary angles, the cosine of a certain angle, let's say I have cosine 30, I'm going to call it cosine alpha, is equal to the sine of a certain angle, which gives me, of course, 60. Sine of 90 degrees minus 30, which is alpha. So this is what's important in this place. We have the complementary angles. That's why the sine of a certain angle, it will give us, for example, cosine of 90 degrees minus alpha. This is another important identity between complementary angles. Now, what about the isosceles triangle, right triangle? I'm going to take also the example of a right triangle which is isosceles. So I'm going to repeat it again. So let's say this is my triangle. That's it. So this is ABC. It is right at A. I know that this side, let's say it's C, and this side is also C. What will the hypotenuse will be C square root of 2. Of course, you can do the Pythagoras Theorem again, and you will be able to find these values. So let's say I'm interested in this angle alpha, which is of course 45 degrees. Alpha is 45 degrees. So sine of 45 degrees, it could be alpha or even the angle C, sine of 45 degrees is opposite, it's BC, over hypotenuse, it's AC. It's C over C square root of 2. It will give you 1 over square root of 2. Cosine of 45 degrees, it's let's say adjacent it's AB over AC is again C over C square root of 2. It's 1 over square root of 2. This is how you find. Let's say you're interested even in tangent. Tangent 45 degrees. You simply say it's sine of 45 degrees over cosine of 45 degrees. So it's 1 over square root of 2 over 1 over square root of 2. The whole fraction will give you 1. So this is how you find actually the values related to the particular angles 0, 30, 45, 60, 90. These are the angles that we are considering in this case. So if you would like to have like a small table where where we can have the different angles and their different ratios that we get by choosing trigonometric functions, I'm gonna give it to you. So let's say we have a certain angle alpha which goes from 0 to 30, 45, 60, and 90, and let's say 360 also. 360, it gets back to 0 because it's the whole revolution of the circle, so it will be the same thing as 0. So let's say I'm interested in sine of alpha. When it's the angle 0, sine is 0, and then 1 over 2, 1 over square root of 2, radical square root of 3 over 2. Sine of 90 is 1. As for 360, it's again 0, just like 0 degrees. What about cosine alpha? So for cosine alpha, it will be 1 square root of 3 over 2, 1 over square root of 2, 1 over 2, 0, and then 1. As for tangent, tangent alpha, so regarding the tangent, you simply have to say it's sine over cosine, so it's 0 over 1, 0. In this case, it's 1 over 2 over square root of 3 over 2, so it's 1 over square root of 3. In this case, it's 1. Here it's square root of 3. 1 over 0, you simply say that it does not exist. Some others say it could be plus or minus infinity, so that's another option. For 360, it will be again 0. And what about cotangent? Cotangent, as we said, it's the reciprocal of tangent, so it's 1 over tangent alpha. So it will be 1 over 0, so it does not exist. In this case, it's square root of 3. In this case, it's 1 again. 1 over square root of 3. In this case, it's 0. And then 360, it does not exist once again. So this is the table that you can actually use in order to have the different values related to the different particular angles and their of course the exact value that you get as a result. So that's all actually for the introduction to trigonometry. I hope it was helpful. Don't forget to subscribe to my channel, so once you subscribe you will be notified whenever I upload new videos, new material. And of course, I'm gonna talk about the unit circle in trigonometric circle, the related associated arcs, etc. It's gonna be in another video. I'm gonna talk about those things. Then I can also share with you my Instagram and Facebook account whenever you have any question, or you can simply leave a comment below. So that's all for today. I hope it was helpful, and see you next time.